We will be presenting today our approach to a decentralized flexibility marketplace in the island of Skiathos in Greece, which is the Greek demonstrator in the context of the ENFLATE project. Our agenda for today, let's say a high-level overview of the ENFLATE project itself, the Skiathos pilot presentation, and then we are going to discuss a bit on blockchain applications in the energy sector, and then we're going to discuss and present the Deflex platform features. It will be an overview of the processes, the functionalities, and the components that constitute the Deflex platform to be deployed in the Skiathos demo site. So as you all know, just a recap for the ones not attending the call, and they will have the opportunity to see the recorded session about the ENFLATE project. So it's a Horizon Europe funded project that it will be use, let's say, existing solutions on data-driven energy services and create new services for the energy sector that are going to be replicated in different geographies to meet the challenges around climate change and consumer needs. Also, the purpose of the ENFLATE project is to propose applicable consumer-centered flexibility platforms and test those platforms in various pilot sites in different countries like Bulgaria, Greece, Spain, Sweden, and Switzerland. And we foresee that through the ENFLATE project, we will engage local consumers as well as authorities, service providers, manufacturers, the academia, as well as TSOs and DSOs to consider using such approaches in the future energy markets. Also, the ENFLATE project will derive and create innovative business models that will also be developed and tested throughout the project that will combine energy services as well as with health and mobility services. Now, regarding the beautiful Skiathos Island, which will be the site for the Greek demonstrator. So, for those that they do not know, Skiathos is an island in the northwest Aegean Sea and belongs to the Northern Sporades group. The island is connected with the mainland distribution network. The area of the demonstration will mainly consider the municipality of Skiathos, the airport, the port, both of the latter under the authority of the municipality. The municipality has a total area of approximately 50 square kilometers, 50,000 square kilometers, where approximately 7,000 residents are situated. And we need to consider the fact that during summertime, Skiathos is a very popular island, so the population can increase up to 10 times more. And this also constitutes a challenge for the pilot. So to meet the demand, the challenge of the demand during the summer period, which are the participating partners in this demonstrator is the National Regulatory Authority of Greece that will also play in the platform, the governing body of the platform, HEDNO and DIPTO, which are respectively the DSO, the TSO, that will provide data into the platform, UPRC. The University of Piraeus Research Institute is the technology provider and the entity that developed the Deflex platform for the Skiathos pilot, and then the municipality itself. What is the challenge here? I mean, the main challenge here is to see how innovative technologies as blockchain can be used to allow small-scale DERs to participate efficiently in energy markets. Right now, in the current setup, small-scale DERs such as residential batteries or let's say EVs can only participate in flexibility markets through their representation via an aggregator. The purpose of the Deflex platform and its role within the ENFLATE project is to test and evaluate how blockchain-based technologies, decentralized technologies can facilitate the efficient inclusion of small-scale DRs directly into energy markets. And these DRs, of course, are foreseen to provide flexibility services to both the DSO and the TSO. Having said that, we are going to test two scenarios, two use cases in the Skiathos island. Use case one is the direct provision of balancing services from devices at the edge of the grid to the TSO. Here, the recipient of the services will be the TSO that will leverage the flexibility provided by the small-scale DERs deployed throughout the Skiathos pilot. The second is towards the direction of exploiting the flexibility for the benefit of the DSO. Against the same devices are going to participate in the flexibility market to facilitate flexibility services towards the DSO, and these services procured are mainly about congestion management and voltage control. What is the expected outcome is demonstrate the way that a decentralized flexibility marketplace based on the concepts of decentralization, blockchain, digital identities, digital identifiers can resolve the challenge and the problem of the direct participation of small-scale distributed energy resources in a cost-efficient manner in flexibility markets. Also, by having flexibility assets participating simultaneously in different energy markets, markets for the DSO and the DSO, will also allow us to demonstrate that this can also further promote the TSO-DSO cooperation and provide to both market participants an efficient and coordinated and above all secure and trusted way of managing the distribution and transmission grids. Below in the table, we list the 4 KPIs that are going to be evaluated during the demonstration in the Skiathos Island. It's the volume of transactions, the number of transactions, the total flexibility requested by the TSO and the DSO, and the number of devices at the edge of the grid that will provide flexibility to the decentralized flexibility marketplace. Now, we are going to discuss a bit on a high level that the way that blockchain technology can bring in value in the energy sector. So we can differentiate between, let's say, 5 main categories where blockchain technologies have been already used to provide services and solutions for the energy sector. So first is about energy trading and creating marketplaces for renewable energy certificates. Here we're mainly discussing about peer-to-peer energy trading, but also we're discussing about the way that energy attribute certificates such as renewable, such as guarantees of origin in Europe or REX or IREX in other jurisdictions can be managed in a seamless, transparent, and trusted manner. Here we leverage the immutable and transparent properties of the blockchain to create registries that keep track of what is being traded in terms of energy or in terms of certificates in a marketplace. We have a lot of examples of ongoing marketplaces, especially in the renewable energy certificates markets, both in Europe, but also in Northern America and Asia. The second, let's say, area where blockchain technology can be applied efficiently is grid management. Here we are mainly focusing on advanced blockchain applications that can significantly enhance the grid management through better analytics and more responsive load balancing. Here, through the concept of decentralized identities and verifiable credentials, we can allow small assets to autonomously participate in services, providing grids management services to both the TSO and the DSO. Another important area where we are using blockchain technology nowadays is the supply chain and origin tracking. So here, energy blockchain is being used to keep track of the origin of electricity from renewable energy sources. Here again, we leverage the immutability and transparency properties of the blockchain technology to create again a ledger, a public ledger, where anyone can independently verify claims that are made around energy coming from renewable sources. So there are a whole bunch of use cases and pilot projects and commercial projects already deployed in Europe and abroad, where let's say blockchain technology is being used for such an application. And I need to highlight here the applicability of blockchain technology, especially in applications where the number of transactions is quite high. So this is well aligned with the 24/7 matching of renewable energy being produced with energy being consumed. So instead of claiming renewable energy on a yearly, on an annual basis, we decrease the time interval down to 1 hour, and this is where blockchain technology can play a significant role. The fourth pillar is the IoT, Internet of Things area, and the energy savings. Here, leveraging again transparency, immutability, trust of blockchain technology, we can enhance the security associated with IoT devices that allow secure, trusted, and reliable data collection and exchange between devices, systems, APIs, and other, let's say, human actors of the ecosystem. Last but not least, is an area that we have seen over the past couple of years being further developed, is the use of the concept of decentralized identities based on blockchain for enabling electric vehicles and charging networks of electric vehicles to either being used for providing flexibility to the grid or allowing the EV owners to opt in to charge with renewable energy only. And here, the role of the blockchain is the technology that allows anyone to prove that a part of renewable energy that has been used for a specific charging session of an EV is not double spent, is not double counted in the books for other charging sessions. So it's all about trust. So instead of relying to a third party to play the trusted party role in the ecosystem, blockchain technologies allows us to embed trust in the system itself. Now, let's dig a bit on the DFlex flexibility marketplace that is going to be defined and deployed in Skiathos. And before discussing the functionalities of the platform and the processes of the platform, let's provide some definitions. First of all, delivery period. It's defined as the time of the day for which flexibility is offered. So for the DFlex flexibility marketplace, the delivery period will be set to 15 minutes. So we will have a 15 minutes delivery period as can be seen here with the blue color. Then we define the gate open time. So for every delivery period, the offer can only be submitted only after gate open time has been declared and before the gate close time. For example, for the delivery period between midnight and 15 minutes after midnight, the gate open will be 15 minutes before and will last till 5 minutes before the delivery period starts. So offers can be sent to the platform in this time interval between the green and the black boxes between gate open and gate close times. So this gate open, gate close time interval is 10 minutes long for participants to provide flexibility. After that, 15 minutes will be used as a buffer for the platform admin to do any sort of configurations, and then 15 minutes interval, the delivery period, it will be the flexibility will be used. Slot numbering. Using this concept of 15 minutes delivery period time intervals, we can split the 24 hours of the day into 96 slots. So for the sake of simplicity, we define as slot number one to the delivery period starting from midnight and ending 15 minutes after midnight, while slot 96 corresponds to the last 15-minute delivery period of the day. And another term that is going to be used is the reservation bundle. So for a specific delivery period, the offers of the assets that were selected based on the provided flexibility and based on the price provided by the prosumers and have been confirmed to participate in the flexibility markets constitute the reservation bundle. So reservation bundle is only the offers of the assets that are going to be actually activated, and not all the offers submitted for this specific delivery period. And this reservation bundle will be used as an immutable proof for the subsequent compensation and settlement of the prosumers providing the flexibility. An overview, a high-level overview of the DFlex platform architecture. We have the marketplace service itself that is responsible for managing the assets, the prosumers, and the organizations. By organizations, we mean TSOs, DSOs that can participate. In our case, it will be the TSO and the DSO, IPTO and HEDNO. Manages the life cycle of the offers, manages the notifications sent to the users for the activation of the assets, as well as the settlement and the further, let's say, future service remuneration. We also have this blockchain component, which will be a public Ethereum-based blockchain that will serve as the trust layer for the decentralized flexibility marketplace. In order to make the solution scalable and computationally efficient, only certain data will be stored on the blockchain, and the execution of all, let's say, business logic will be handled automatically through smart contracts that will be deployed on the blockchain. Distributed storage, a distributed storage system will be used mainly for the sake of customization. When we are talking about actors in the context of the DFlex platform, we refer to prosumers, the TSO and the TSO, as well as installers. So installers are, let's say, authorized entities that are allowed to install the devices of the decentralized DFlex market to the participants' premises. TSOs are participating in the DFlex platform mainly by creating requests for flexibility, as well as managing offers and performing asset activations. And the DSOs are mainly responsible for adding constraints related to the physical network capacity, but also leveraging themselves the flexibility mainly for congestion management and voltage control. We have also assets bind to the DFlex platform. And these assets refer to prosumers, flexibility assets that offer flexibility and get remunerated for the provided services. And last but not least, we have a fully-fledged API, application programming interface, that allows any future integration of TSO, DSO, information technology and operation technology systems, as well as with prosumers, energy management systems and services. Now, we are going to briefly discuss about the core functionalities of the DFlex platform. So the main functionalities that the DFlex platform offers are the following. First and foremost is the onboarding of flexibility assets. This is a very important aspect of the platform because it mainly focuses on authentication and authorization of the assets that are allowed to participate in the platform and provide the flexibility. And this is done by assigning to onboarded assets digital identities by form of a public-private key combination. The onboarding takes place by grid operators that are able to pre-qualify type of flexibility assets. For example, a battery of a specific model produced by a specific manufacturer, and then a qualified installer that has been authorized by the DFlex platform verifies that the customer's asset is of that type and is located behind the customer's energy meter. The second core functionality of the platform is the participation in flexibility markets. This mainly includes all the services that allow the TSO and the DSO to submit their requests and network constraints into the system, allows assets to submit their flexibility offers, and then by running through a scheduler on a periodic interval, a merit order algorithm, the selection of the lowest cost offers that meet the flexibility requests procured by the TSO of the DSO. And then activation functionality refers to the whole notification system that notifies the user that the specific asset has been accepted to participate in a specific delivery period, and this asset needs to be activated by the prosumer. And then the fourth step is about settlement. It's all the services here related to how asset owners are being compensated for their asset being activated within a specific flexibility period and based on the offer submitted by the asset owner. And this offer has two components. One is the amount component, how much flexibility was offered, and the second component is the price, at what price this flexibility was offered by the asset owner. Now here we present the five key actors of the DFlex flexibility platform. First of all, we have the DFlex administrator. So the DFlex administrator is the administrator of the marketplace, and it's the entity that is responsible for approving the registrations of organizations, such as the TSO, the DSO, and the authorized installers. Then we have the TSO. The role of the TSO is to create flexibility requests, accept the reserved bundles of flexibility offers, and then activates by means of notifications the assets that were selected, and of course confirm their participation for the specific delivery period. Moreover, the TSO can also define physical constraints for the request flexibility. A similar role also is being attributed to the actor, the DSO actor. Again, DSO can also create flexibility requests, define physical network constraints on the distribution grid, and this constraint, along with any constraints imposed by the TSO, will be taken into the merit order algorithm for the selection of the most economical flexibility offers that fulfill the flexibility requests. Then another key actor in the platform is the asset owner, which is the owner of the flexibility asset. The main role of the asset owner is to define certain offer parameters so that the asset can submit an offer that is consistent with those parameters. And in the DFlex platform, these parameters are the time of the day, the time slot of the day where the asset is going to participate with the flexibility offer, the amount of flexibility offered for this specific delivery period, and the price for the offered flexibility within this 15-minute delivery period. We need to say here that this 15-minute delivery period is fully customizable. So we can simply, let's say, adjust 15 minutes down to 5 minutes or 1 minute or 1 hour or whatsoever. So this is a parameter in the platform that provides full flexibility to anyone to customize this as per their needs. Last but not least, a core component of the Deflex platform is the installer. So by installer here, we refer to the authorized entity by the administrator that is responsible for approving the registration of the assets and their participation in the flexibility market. So what we are doing here is that we delegate the responsibility of the DSO or TSO to pre-qualify, register, and onboard assets to a trusted installer. And by using blockchain technology, cryptography, and public-private key cryptography, we manage to delegate this authority of asset onboarding to installer without compromising at all the security and the trust associated with the Deflex platform. Here we provide an overview of all the platform processes that are implemented within Deflex Marketplace. Needless to say that all these processes are supported both through the UI, the user interface of the Deflex platform, but also are available as API endpoints for anyone that would like to use Deflex platform by binding it, integrating the platform to their existing OT, operational technology or information technology systems. Here, the processes are the actor registration, which is registering an actor itself, like a TSO, a DSO, an installer, or an asset owner. The organization approval. So upon submission of a request, for example, from an installer or a TSO or a DSO, the platform admin is able to either, let's say, accept or reject the organizational registration. Then we have the registration of the assets themselves. So here the installer registers the assets, installs the assets, and then through the platform it registers the asset to the internal Deflex registry. Then it's the approval of the asset that this registered asset is now approved to offer flexibility and flexibility offers to the platform. The processes of offer creation and offer submission that also support deletion, confirmation, and edit of the submitted offers. Then we are also able through the platform to add physical constraints related to the network, edit those constraints, and also delete those constraints. The platform and the API also allows us to add the flexibility request, edit the flexibility request, and delete the flexibility request, accept the reservation bundle, which means that, yeah, these offers are now confirmed and approved to be activated within the specific delivery period of 15 minutes. And then it's the asset notification and activation. And last but not least, how we deal with the settlement and the remuneration for the asset owners. A key component here is the Flex Edge device that will be deployed in the prosumer premises. What are the main components of the Flex Edge device? Is the MQTT client, the JWT engine, secure element, offer scheduler, local storage, Web3 client, and message logging. What all these modules perform can be seen here. So the MQTT client is a message broker that allows the Flex Edge device installed and deployed at the customer premise to communicate with the marketplace. And this communication consists of two components. First of all, it handles all the communication about the offer management. Like, for example, an asset owner creates an offer. This offer is then created on the Flex Edge device. Then this software is digitally signed on the FlexEdge device, and then this offer is sent to the marketplace, and then the marketplace will verify the digital signature of the offer to verify that this offer actually came from the asset that in the first place is sending the offer, submitting the offer, and then either accept or reject this offer. And then the whole notification activation part is the notification between the platform and the marketplace, so the marketplace and the FlexEdge device, that a specific asset behind this FlexEdge device needs to be activated. The JWT engine, which is a JSON Web Token engine, is the engine that is the module that is used for creating the digital signature that is used for verifying the offer of an asset. So this is of paramount importance for the whole operation of the platform. So the whole design of the platform is based on the fundamentals of public-private key cryptography. So every single message, every single offer that is submitted from the FlexEdge device to the platform is digitally signed by the private key stored within the secure element, the hardware wallet of the device, and then verified on the marketplace side by the private key, by the public key corresponding to this private key. This ATCC608B secure element is the hardware wallet that holds the private key for a specific asset. So this is very important because the private key never leaves a secure element, and therefore the private key is only known to this specific asset and only to this asset, and therefore no one else can impersonate an offer that is being sent by this asset. The Web3 client module inside the FlexEdge device is responsible for the communication with the blockchain. And then we have the offer scheduler that schedules the activation of the assets and the notification of the asset owner. The local storage that is used for storing local configuration, as well as all the offer records in the case that there is a power outage and the FlexEdge device needs to be rebooted. All the information, configuration files, and offers are loaded during boot time from the local storage. And then, of course, we have a detailed message logging module to keep trace of what is happening on the FlexEdge device side. And then, of course, we have this Balena Cloud, which is the platform for managing the whole fleet of FlexEdge devices to be deployed in the Skiathos pilot site. So the FlexEdge device has been built around Raspberry Pi SBC single board computer with the addition of this secure element that is connected to the headers of the Raspberry Pi. So this secure element is the hardware wallet that connects this device to the blockchain. So this hardware wallet is the storage of the private key that uniquely identifies every single FlexEdge device. Now, as we mentioned, we are going to use Balena for the FlexEdge devices. So Balena is a trusted platform for IoT device management. So it allows easy deployment, remote management, scalability, security, version control, monitoring, logging, and cost effectiveness. In a nutshell, how Balena works. So you create a fleet on Balena. You assign to this fleet FlexEdge devices, IoT devices, and then you manage the operating system on these devices through a single portal. This means that if we need to update the firmware of the FlexEdge devices, this can be done remotely simply by pushing a change of the operating system to Balena, and then Balena will be responsible for propagating these changes down to the Flex devices connected to this specific fleet managed through the Balena cloud infrastructure. Now we're going to spend 10 more minutes approximately to dig a bit through the marketplace operations and see how this works from a system perspective. A key operation for the marketplace is the actor registration. So the process of registering an organization is shown in the form of the sequence diagram in this slide. It should be mentioned that this process applies to all organizations like TSOs, DSOs, and installers that need to be approved before being able to interact with the platform itself. So we start with step one here. So step one is the organization submits an organization registration claim to the DFlex platform. The DFlex platform issues a request for a decentralized identity to the registry. The registry then generates a public-private key pair that is sent to the organization. Then the organization digitally signs this registration claim and sends this claim to the registration to the DFlex platform. And then this claim is sent for final approval to the administrator of the platform. This we discussed this earlier, that all organization registrations, TSO, DSO, installer registration are subject to platform admin approval. So if the platform admin approves the organization registration, signs the registration claim with a platform admin private key that is only known to the admin of the platform, and this key is then sent and stored to the DFlex platform, and also a registration notification is sent back to the organization. So this flow takes place, this sequence takes place every single time a new TSO, DSO, or installer is being registered with the platform. And as we discussed, the approval is subject to the approval or rejection by the admin of the platform. A similar flow that is using these claims, claim is information technology term, is used also for the asset registration, but in this case, it also includes interaction through the MQTT broker with the Flex Edge devices. So when an asset owner wants to register a new asset with the platform, sends a request for asset registration to the DFlex platform. So what the DFlex platform does, it creates an asset registration claim that is being sent to the operating system of the Flex Edge device. Then the operating system of the Flex Edge device interacts with the secure element, gets back the public key, updates the public key in the claim, and then is sent. This claim, now populated with the public key, is then sent back to the secure element for digital signature with a private key, and the signed asset registration claim is then sent back to the operating system. And then this request now of asset registration is sent to the installer and waits for the installer approval. Once the installer approval has been made, and this again is being made by having the installer sign this asset registration claim with the private key that is only known to the installer, then this claim is sent back to the DFlex platform for permanent storage. So you see that all interactions within the platform rely on this public-private key cryptography, which is the essence of this decentralized flexibility platform that allows the platform, the DFlex platform, to scale up with low cost, and also is what it enables this platform to be fully decentralized, because you do not need any third party to be the trusted party, because everything is managed through public and private key cryptography. Now I'm going to zoom a bit here. Here we're discussing how an asset life cycle is managed by the Deflex platform. So when an offer is first created through the UI of the Deflex platform, an offer creation signal is sent to the operating system of the IoT device of the Deflex of the FlexEdge device. So when this offer request is sent, first of all, the operating system checks the validity. Is it a valid offer, valid price, valid amount, valid date, valid time? If the offer is not valid, then an offer rejection message is sent back to Deflex. But if the offer is valid, then the first step is to check if the offer exists. If the offer exists, and meaning that a similar offer with from the same asset for the same delivery period already exists, then we modify the existing offer data. Then, if it's a new offer, we store the new offer and we schedule offer for submission to the scheduler. Once the gate open time has been reached, meaning that the assets are now allowed we were 15 minutes before delivery period, and now assets are able to submit offers. The scheduler automatically submits this offer to the operating system. The operating system sends the offer to the JWT model to create this digitally signed offer. This offer is sent back to the operating system, and then this digitally signed offer is sent back to the Deflex platform. The Deflex platform, of course, performs all the necessary security checks, check if this is a valid digital signature sent by the asset, if it corresponds to the asset ID, and so on. And if it is a valid offer, it runs this merit order algorithm once the gate close time has been reached. And if the offer is economically viable offer, then it adds this offer in the reservation bundle. And then it finally sends back to the asset owner a request for confirmation. This request is like, look, your offer has been accepted for activation. Please send your final binding confirmation that you are accepting to participate in this 15-minute delivery period by switching on or off your asset. Again, this request is received by the operating system of the FlexEdge device. A digital message is being created by the JWT module, and this message is sent back to the operating system that forwards this offer confirmation to the Deflex platform. Then, when the delivery period starts, activation signals and notifications are sent to the asset owner, and the whole activation cycle starts. Once the delivery period starts, then calculation of the amount of flexibility offered by the asset is being performed, and then remuneration and settlement takes place. So this is, in a nutshell, the way that the life cycle of an asset is managed by the life cycle of an offer of an asset is managed by the platform, and it is the way that we handle all the offers from assets. And since this is fully automated and driven by the fact that every single message is being signed and verified by means of public-private key, this process is fully automated and can be fully scaled up. Last but not least is the settlement process that takes place between the Deflex platform and the blockchain. So here on the Deflex platform, we generate the Merkle tree. The Merkle tree is a key component in blockchain cryptography. So it's a proof that a specific offer ID corresponding to an offer was included in the assets being activated. And this Merkle tree root hash is then anchored and stored permanently in the blockchain. This means that anyone in the future can independently verify whether a specific offer was included in the reservation bundle and then check if they were compensated or not. This is the way that the Deflex platform handles transparency and trust when it comes to offer selection, offer activation, and asset owner remuneration. Yeah, and then this is it. This is what we had wanted to present to you today about the flexibility platform based on blockchain technology for the Skiathos Island. Happy to answer any questions. Thank you for attending.
Janos, I will have a question. I'm curious about if the Semo site can also be adapted to other regions and to other places.
Thank you, Rosalie, for the question. Yes, this is why all parameters when it comes to actors like TSOs, DSOs, installers are fully customizable, as well as the way that the flexibility market operates when it comes to gate open, gate close, delivery period times. These are fully customizable. It's just a parameter in the platform so that we can make sure that all these can be replicated in other geographies. And also, we need to state that the whole concept of handling the digital identities of assets and actors is being performed using the concept of decentralized identifiers and verifiable credentials that are based on open standards like W3C standards, so that we do not have any sort of vendor lock-in, and that the solution can be replicated in any project in any geography.
Okay, thank you. Are there any other questions?
I would maybe have one. Yeah, first of all, thanks for the presentation. My point was regarding the willingness of participants to be activated. How, because for now, from the way I understand, right, you just got the IoT sensors and the activation happens automatically. How do you take that into account in the bidding process, to the extent to which participants give control on the volumes activated?
Thank you for your question. So, since the majority of the participants have assets that are not that cannot be directly controlled, so we're talking about water heaters or any other, let's say, highly consuming asset. The way that the activation will take place will be through notifications sent to the mobile or email accounts declared by the participants. Also, what will be taken into account during the bidding process is the responsiveness of the prosumer. So, for example, we're going to keep track of the actual activations of assets being confirmed that will participate in a specific delivery period. This means that the merit order algorithm will also assign higher probabilities of selection to prosumers that fulfill their obligation to participate in a specific delivery period if they have confirmed their participation in this delivery period. Otherwise, prosumers that have declared that they will participate but they didn't actually participate, they will be penalized through the offer flexibility offer selection process.
They will pay the imbalance cost essentially that they caused. Okay.
Yeah. But since we cannot make them pay, it will be some sort of penalty, let's say reputation-based system.
Okay, thanks.
Thank you.
Are there any other questions? If not, then I want to thank Yannis for this nice presentation and for the insights of the project, and to thank every one of you to join. And then I will close the meeting and wish everyone a good day.
Thank you. Bye.
Thank you. Ciao.
Thank you. Bye bye.